Hello! In this set of examples, ang titignan naman natin ay logarithmic equations. And for my first example, I want to solve for x in the equation log base 16 of the quantity 3x plus 1 over 2x minus 5 equals log base 16 of the quantity square root of 3x plus 1 all over 2x minus 5 plus 1/4. So, hanapin natin yung x sa equation na ito. Now, what I would like to do na first step ay gagamitin ko yung power rule ng logarithms. So, wala muna akong gagawin sa left side. But on the right-hand side, the logarithm of the square root, this is equal to 1/2 of the logarithm base 16 of the quantity 3x plus 1 over 2x minus 5 plus 1/4 pa rin. Walang nagbago doon. Now, notice na sa left-hand side, meron tayong log 16 of something. Sa right-hand side, we have 1/2 log base 16 of something. We could just subtract 1/2 log base 16 of 3x plus 1 all over 2x minus 5 from both sides. And on the left-hand side, we will have 1/2 log base 16 of 3x plus 1 over 2x minus 5. And on the right-hand side, we'll have 1/4. We could multiply 2 to both sides muna. So we'll have log base 16 of 3x plus 1 all over 2x minus 5 is equal to 1/2. And then, we can use yung definition natin ng logarithms and exponentials na ang log base 16 of 3x plus 1 all over 2x minus 5 equals 1/2, equivalent siya pag sinulat natin na 3x plus 1 all over 2x minus 5 is equal to 16 raised to 1/2. Ito yung definition natin ng logarithms. But 16 raised to 1/2 is the square root of 16. And the square root of 16 is equal to 4. So we'll have 3x plus 1 all over 2x minus 5 equals 4. Multiplying 2x minus 5 to both sides, we'll have 3x plus 1 equals 4 times 2x minus 5 or 8x minus 20. Combining all the x terms to the right side, we'll have 5x. And sa right-hand side, we'll have positive 21. So parang nag-subtract akong 3x sa both sides, nag-add akong 20 sa both sides, then pinag-switch ko yung positions nila using the symmetric property of equality. And we'll have our final answer, which is x is equal to 21 over 5. On to our second example on log equations. We want to solve for x in the equation log of x squared is equal to the quantity log of x quantity squared. Tignan natin siya saglit at isipin natin paano natin sisimulan. So, pinakamadali, sa left-hand side, pwede nating invoke yung power rule and we could rewrite this as 2 log of x is equal to the right-hand side. Walang nagbago. Now, pagdating natin dito, medyo suggestive na siya, no? Mayroon tayong log of x, mayroon tayong log of x squared, na baka pwede natin siyang i-treat as a quadratic. So, let's use substitution by defining a second variable and letting u be equal to log of x, and rewriting our original equation as 2u is equal to u squared. Let's rewrite this as a quadratic. We'll have u squared minus 2u equals 0. Factor it and into u times u minus 2 equals 0. And we'll have u equals 0 or u equals 2. Now, we could back substitute. Ano ulit yung u is log of x. So, log of x equals 0 or log of x equals 2. Are these two values possible? Nasa range ba sila ng logarithm? Ang range ng logarithm ay all real numbers. So, okay lang. Now, what is log of x equals 0? That is the same as writing x is equal to 10 raised to 0. Diba? Kasi ang log na hindi define yung hindi natin nakikita yung base ay log base 10. And log of x equals 2, we could write this as x equals 10 squared. Final answer, we have x equals 1 or x equals 100. On to our third example on logarithmic equations. We want to solve for x in the equation 7 raised to the quantity log x of 7 equals 6. So yung x nasa base ng isang logarithm na nasa exponent ng isang number. Now, what we'll do is we'll use the definition of logarithms. Na b raised to x equals y, this is equivalent to x equals log base b of y. So, susulat ko siya ngayon na log base x of 7 equal to log base 7 of 6. So, pause tayo saglit just to verify na tama yan. So, okay tayo dyan. Next, we'll apply the definition again and write this as 7 equals x raised to log base 7 of 6. Pause ulit tayo to make sure that you follow. What I will do is I will take the logarithm of both sides again. Bakit ko gustong gawin yon? Kasi gusto kong ibaba yung exponent na nandun sa x. Hindi ko siya mabababa normally, but if I take the logarithm of both sides, I can make use of the power rule. So anong base gagamitin ko? Pag nag-logarithm ako ng both sides, base 10 ulit? Maybe I'll stick with base 7 kasi meron na tayong existing logarithm doon na base 7. So I'll take the logarithm of the left-hand side. That will be log base 7 of the quantity x raised to log base 7 of 6. This is equal to the right-hand side, which is log base 7 of 7. I hope at this point makita natin na yung right-hand side ay equal sa 1. Na ang log base 7 of 7 is just equal to 1. Pero hindi muna natin siya isi-simplify. On the left-hand side, gagamitin muna natin yung power rule at ibababa natin yung exponent na log base 7 of 6. And rewrite the left-hand side as log base 7 of 6 times log base 7 of x. This is equal to log base 7 of 7, which we should know na equal to 1. Now, let's divide both sides by log base 7 of 6 para yung left-hand side maging log base 7 of x, yung right-hand side magiging log base 7 of 7 over log base 7 of 6. Anong pupuntahan natin dito? Hopefully, makita natin na ang pupuntahan natin dito ay change of base formula at yung right-hand side ay equal sa log base 6 of 7. Next, we'll apply the definition of logarithms again. We'll write this as x equals, yung base niya which is 7, 7 raised to the right-hand side, or x is equal to 7 raised to log base 6 of 7. And I don't think we could get any simpler than that, so we'll declare that as our final answer. For our fourth example on logarithmic equations, we want to solve for x in this equation. So 81 times the quantity log base 27 of x plus 1, close parenthesis to the fourth power, minus the open quantity log base 3 of x squared plus 2x plus 1, quantity squared, plus 3 equals 0. So, before we proceed, tignan natin kung paano natin ito i-attack. Let's observe first, no, na hindi lang pareho yung base ng dalawang logarithms natin. Isang base 3, isang base 27. We might need to convert both bases into a common base. So, we could choose kung gagawin ba natin silang parehong base 27 or base 3. It seems mas logical kung base 3 yung pipiliin natin kasi mas maliit siya sa 27. So, let's go in that direction. So, I'll work on the first term first and rewrite it as 81 times the quantity log base 3 of x plus 1 all over log base 3 of 27 using the change of base formula. But this whole thing is still raised to 4. Let's observe, no, na yung argument nung log base 3 sa second term ay x squared plus 2x plus 1 and we can write it as x plus 1 squared. So, we'll have the second term as negative log base 3 of the quantity x plus 1 squared and the whole thing is still squared pa rin. Plus 3 equals 0. Now, what do we know about log base 3 of 27? Log base 3 of 27, ito yung exponent kung saan natin i-raise 3 para maging 27. So, that is equal to 3. So, the whole thing is still raised to 4. And then, we could make use of the power rule. Yung exponent nung x plus 1, pwede na natin siyang ilipat sa coefficient nung logarithm para maging 2 log base 3 of x plus 1. And the whole thing is still squared. Plus 3 equals 0. Now, let's make use of the fact, no, na yung 3 na yan, that is also being raised to the 4th power. And that 3 to the 4th power is equal to 81. So, we're essentially dividing yung first term by 81, and that should cancel out with the coefficient na 81. To leave us with just log base 3 of x plus 1, quantity raised to the 4th power, minus, yung 2 naman, pwede natin siyang square, so magiging 4 times the quantity log base 3 of x plus 1 quantity squared plus 3 equals 0. Let's take a short break to see na tama yung ginawa natin dito. So once you've assured ourselves na tama yan, let's proceed. So makita natin na baka pwede na naman natin siyang express as a quadratic. So what we could do is we could define a second variable, variable u, at tawagin natin siyang log base 3 of x plus 1 quantity squared. And we should be able to write this equation as u squared minus 4u plus 3 equals 0. This factors to u minus 3 times u minus 1 equals 0, or u is equal to 3 and u is equal to 1. Now, back substitute tayo. Ang u ay equal sa log base 3 of x plus 1 quantity squared. So we could write this as log base 3 of x plus 1 quantity squared equals 3, or log base 3 of x plus 1 quantity squared equals 1. But if we take the square root of both sides, we'll have to consider two values. So yung positive square root of 3, tsaka yung negative square root of 3. On the second equation, that will be log base 3 of x plus 1 is equal to positive 1. Sulat na rin natin yung log base 3x plus 1 doon. And log base 3x plus 1 is equal to negative 1. So we have 4 equations that we need to solve. So taking the first case, this will be equivalent to x plus 1 is equal to 3 raised to square root of 3 by the definition of logarithms. So x is just equal to 3 raised to square root of 3 minus 1. And this is one of the final answers. Taking the second case, log base 3 of x plus 1 is equal to negative square root of 3. This is equivalent to x plus 1 is equal to 3 raised to negative square root of 3. Or x is equal to 1 over 3 raised to square root of 3. Bakit? Kasi ang negative exponent, diba, pwede nating isulat na reciprocal minus 1. And this is a second final answer. Third case, we could write this as x plus 1 is equal to 3 raised to 1. Subtracting 1 from both sides, we get x equals 2. And for the final case, we can write this as x plus 1 is equal to 3 raised to negative 1. But 3 raised to negative 1 is the same as 1/3. So we could subtract 1 from both sides and we'll have x equals negative 2/3. And this is our fourth final answer. I'll see you sa next video natin.